which is a big quiz compared to our normal quizzes. So the only, if we have time, at the end of the period when our lesson's over, we'll review some more. Otherwise, what we did yesterday and what we're doing right now is it. And you're going to have a quiz tomorrow that's going to look just like this, okay? Now, we have a last problem to do. It says, sketch. Now, it's not asking me to do the problem. It just says, sketch the vector representing the course of an airplane on a bearing of 220 degrees, traveling at 190 miles an hour. Okay? All right, so here we go. Who remembers the rule when we are doing directions? Airplanes or ships or something like that. Who remembers the rule? Uh-oh. Where do we start our angles? Top. Very good, Blake. We start up here. We never start there in any other problem that we do. But if it is a direction, we start up there. And which way do we go? Clockwise or counterclockwise? Clockwise. Clockwise. So this is 90, this is 180, and this is 270 on the compass. If you're doing direction, that's how you do it. So when it says a course of 220 degrees, where are you going to put 220 degrees? You're going to start here. And you're going to go, and stop here, right? Now, exactly where you stop is not important to me, but you got to be in this quadrant, right? And so you're going to draw your course, and it's going to look like that. And then you're going to mark this 220 degrees, because that's how far you went. And then there's one more thing you have to put in the picture. Now, if we were actually going to do the problem, we would make a triangle and all that, but we're not. We're just drawing it. But there's one more number. You got to put a 190 in there somewhere. Where does the 190 go? (190) is the magnitude of the vector, kids. It's how fast that airplane's going. So that's what the picture looks like. We talked about that. We did problems like that. It's in your note sheets. Now we've done a practice one. Okay? You got to keep up with it day to day. Remember, we're not reteaching every day. We've already been through all this. Speaking of reteaching, let's get out our note sheets and let's get a new lesson learned today. And here's how the next few days are going to work. We're splitting this chapter up, and so today we're going to learn 6-3. Tomorrow we're taking our quiz, and then we're going to start reviewing. We'll review again on Friday, because no school on Thursday. And on Monday, you have a quest over 6-1 to 6-3.
Are you going to be here?
On Monday, I will be here. Yes. All right, so here we go. I'm on my note sheets, page 51. Page 51. Everybody on page 51. Eliminate the parameter. Now, this is something new. These are called parametric equations. T is called the parameter. Now, how these equations work is some situations operate better parametrically. We're not going to go into great detail here, but here's how it works. Pick a t value. Pick any number for t. What's the number?
7.
7. If you put 7 in here for t, would that give you an x value? Yeah. And if you put 7 in, would that give you a y value? So if you picked t equals 7, you could get an ordered pair, right? An x and a y. What if somebody else picked t equals 5? They would get another point, maybe a different point, but another point. And somebody else could say t equals -2. So what do these allow us to do? Just generate a whole bunch of points. Okay, so that's what parametric equations do. Your job is to eliminate the parameter and tell me what shape we have. What curve does this describe? If we made up a whole bunch of points and plotted them, what shape would we get? Well, I don't want to take the time to do that. Instead, I'm going to eliminate the parameter. So here's what I want you to do. I want you to take that top equation, and I want you to get t by itself. So if you took that top equation, what would t equal? X minus 1. That's easy. Now, take this value right here and substitute it in to the other equation. So you see what I'm doing? So t is this, so I'm going to put that in there. So it's going to be y equals 3 minus 2 times x minus 1. Or y equals 3 minus 2x plus 2. Don't forget you're distributing. Or y equals negative 2x plus 5. If I just simplify all of this. Now, that set of equations is exactly the same as this. Can you tell me what shape that is? That's the second part of the question. Y equals mx plus b. That's a line. So step 1 was eliminate the parameter. That means write an equation that doesn't have a t in it. The parameter is t. Are there any t's left? Nope, I got rid of them. Then look at the equation you got and tell me what shape that is. Well, that's just a line. That's all it is. Now, let's try the next one. B. We're going to do exactly the same thing. So, using the last one as an example, how do you think we might start? Get t by itself. Now, does it make any difference which equation you use to get t by itself? No. So use the one that's easiest for you. I always have trouble with these negatives, so I'm going to do this one this time. What does t equal in this equation? Y minus 3. Now, what am I going to do with the y minus 3? So I took this equation and got t by itself. Now, what am I going to do with this? Plug it in now to the top equation. So x will equal 2 minus y minus 3. So x equals 2 minus y plus 3. And x equals negative y plus 5. Now that equation isn't quite written like I normally would want to see it, but it's okay. Can you tell me what shape that is? It has an x and a y in it. Isn't that another line? Now it's not written in y equals mx plus b form. You don't have to do that unless you want to. That's just another line. If I rearranged it, it would be y equals negative x plus 5. You don't need to do that, but if you did, that's what it would look like. It's just another line. Is that okay with everybody? All right, let's look at the next one. This is a little harder now. But you're going to do everything exactly the same way. Alright, so what's step one? We are eliminating the parameter. That means get rid of t. Fancy way of saying get rid of t. What is the first thing you're going to want to do? Get t by itself. And I would suggest we do that right here. Now be careful, it's a little bit fancy. I get t by itself. I'm going to, let's see, I'm going to add the t over to here and subtract the y. So I got 2 minus y for my t value. Now you may have done things in a little bit different order, but did you get 2 minus y? Now, what do we do with that? Plug it in to this equation. So x is going to equal 2 minus y squared. So x equals, okay, I'm going to FOIL that. So that would be 4 minus 4y plus y squared. Because anytime you have a quantity squared, you're going to FOIL it. Now, is that a line? No way, Jose. Do lines have squares? What has squares? Parabolas. This one is a parabola. Because it has a squared variable. All right, one more. Step one. Hannah, what are we going to do first? On that top equation, right? That's going to be the easy one. So we'll get t by itself up there. So Hannah, what does t equal?
T equals x minus 1.
Perfect. Claire Mahoney, now I've got, Hannah's got t equals x minus 1. What is she going to do next? Plug it in right here. So we're going to have x minus 1 squared minus 2. Is that okay with everybody? PJ, are you writing any of this down?
Yeah, no.
You might want to consider doing that. Anytime you have a quantity squared, you know that's going to be a FOIL. So we're going to do FOIL. So I got y equals x squared minus 2x plus 1, and then minus that 2. So y equals x squared minus 2x minus 1 is my final answer. And once again, what shape is that? A parabola. Everybody okay with that section?
Do we have to graph these?
Nope. You do not. You do not. All you have to do is rewrite the equation without the t and then tell me what shape it is. And I don't try to trick you. What are the two shapes you're responsible for? Parabola and line. And how do you tell the difference when you get your answer? If it's got a squared in it, it's a parabola. If it doesn't have a squared in it, it's a line. Nothing tricky or hard. All right, next. 2 points. You're going to write the parametric equations. All right, I need everybody paying attention. This is brand new. It's easy, but I need to help you with it. Ultimately, we're going to come up with 2 equations, an x equals and a y equals. These are parametric equations. But before we do that, we got an intermediate step. we're going to write the vector equation of the line. Now this is easy. The format of the vector equation of the line is this. So every time you have a problem like this to do, I want you to start by setting this up. X comma y equals parentheses, point, ordered pair, plus t times another parentheses, another ordered pair. Every time, this is your first step. When it says, write the parametric equations of the line, you're going to start with this setup. And then you're going to fill in these two blanks. Now, in the first blank will always go your starting point. That makes sense. First blank, starting point. Kind of makes sense. Where do we start? Where do we begin? Well, in this problem, we begin at 1, 2. Now, the temptation always is to stick 3, -4 in here, and that's not what goes there. What goes here is the direction vector, which is really just the slope. It's how the line moves. How do you get from point A to point B? How do you move, getting from point A to point B? Well, we went from 1 to 3. So how did we move in the x direction, going from here to here? 2. That's what goes right there. And then in the y direction, we went from 2 to -4. Watch it. -6. So what goes in the first blank? Starting point. What goes in the second blank? Not the other point. In the second blank goes, how do you move? 1 to 3, 2 to -4. Everybody okay with how I filled in those blanks? Now I'm ready to write my parametric equations. We're simply going to split this up. We're going to take all of the x pieces and put them together. So what does x equal? X equals 1 plus 2t. What does y equal? Y equals 2 minus 16. And there's the answer to the question. Those are your parametric equations. Your parametric equations are x equals and y equals. So you take the vector equation that you wrote and you simply separate it into the first parts and the second parts of the parentheses. The x parts and the y parts. See how that works? All right, let's try the next one. Our 2 points are 3, 6, and -1, -2. Ultimately, x equals y equals is going to be my answer. But I don't go there first. What did I tell you to do first? Write the vector equation. So that's xy. That's your vector equation. You're just going to have to memorize that format. All right, so now we can fill in the blanks. What do we put right here? 3, 6. Everybody good on that one? Now, what do we put here? Not that. How does this line move? It goes from 3 to -1. -4. It goes from 6 to -2. -8. Everybody okay with the blanks filled in that way? So now you're ready to separate. what is x going to equal? Look at the first part of each parenthesis. What is x going to equal? 3 minus 4t. Everybody see it? Now's your chance to ask if you don't. Everybody see it? 3 minus 4t. What does y equal?
6 minus 8.
And there are your parametric equations. Two more, and then we can review a little bit more. We're getting through this kind of quickly. Part C. Our points are -2, 0, and 1, 1. All right. Cole Peterson, what am I going to put right here? This is my vector equation now, my starting point. What am I going to put here? -2, 0. Now, Sam Blanchett. What do I put here? This is the hard one. Do not put this point in here. That is not what goes here. Sam, what's going to go there? 3 and 1. Perfect. That's how the line moves. Up 3, up 1. Right? Or right 3, up 1. So now I'm ready to write my parametric equations. Connor, what are my parametric equations then? Straight from here. What are they? X equals what?
It's x equals -2 plus 1 t or 0 t.
No, when we write our parametric equations, x is all the first parts. So x is -2 plus 3t. X is the first part of every parenthesis. So Connor, what would y be then?
Plus 1t.
Yep. There we go. Everybody okay? All right, do the last one on your own. Do the last one on your own. I'll do it up here. We'll see if we match answers. Come on, everybody. Let's so we have a little more time to review for our quiz tomorrow. Everybody's doing B. Lily, here are my final answers down here. And if you have a question or concern, do I have a mistake? Do you agree with me? Think we're okay? Everybody all right with that? Last call on that. Everybody good? All right. If you get out a packet that I gave you that has your practice quests in it, on the very front, I gave you this packet a few days ago, everybody has it. On the very front, it says Precal C Quiz 6-1. And then all of the other pages, kids, are your pre-quests, okay? So don't lose this packet. These are your pre-quests, but on the front, I have an old quiz that we can practice. Now, this is a quiz from another year. Your quiz tomorrow is going to look exactly like the practice quiz that we did, okay? We're going to practice these problems because they're possible quiz questions. But remember, your quiz tomorrow is going to have 8 questions. And the 8 questions are going to match up with the 8 that are on the practice quiz. Everybody clear on that?
Yeah.
All right, this is just extra practice. All right, so here we go. Number 1. Everybody's in this packet, front page. Number 1. What are we even talking about when it says find AB? What are we looking for? What do we call what we're looking for? It starts with a C. There's 2 possible words.
Coordinates.
Coordinates. We're looking for the vector coordinates. Or, what's the other word we have? Components. We are finding the coordinates of the vector that goes from A to B. Well, you've done that today already. A to B. What are the coordinates of the vector? 7, -1. How do we get from -1 to 6? We take 7 steps. How do we get from 2 to 1? We go backwards 1. Those are the vector coordinates. That's how you write a vector. A vector tells you how you move. Right 7, down 1. Everybody got it? That's a quiz question on your quiz tomorrow. All right, number 2. So we know that V has coordinates -2, 3. What does this mean? What are you supposed to be looking for? The magnitude. That notation means magnitude. And how do we find magnitude? Pythagorean theorem. So if you want to draw a picture, you absolutely can. The vector goes left 2 and up 3. So what would be its magnitude? Doing the Pythagorean theorem, the magnitude would be the square root of 13. We talked yesterday that you never have to draw a picture. Ultimately, to do this, all we did was square those 2 numbers, right? So if you don't want to draw a picture, that's perfectly fine. That's up to you. Vocabulary. Magnitude is another word for length. All right, next. We are finding V plus U. Now, first of all, this is an addition problem, and we have a vocabulary word for vector addition also. What do we call the answer to a vector addition problem? I told you this yesterday.
A resultant.
The resultant. We are looking for the resultant. What is the resultant? The sum of 2 or more vectors. We're finding the sum of these 2 vectors. Find the resultant. Add them together. What do you get when you add V and U together? -1, 7. If you miss that, it's embarrassing. You add the X's and you add the Y's. C. Back to, here's vector V again. Now we're finding 2V, another vocabulary word. What do we call 2? That's called the scalar. What would the coordinates of 2V be? If this is V, 2V would be -4, 6. That is not a bonus. That's a question on your quiz tomorrow. Find a unit vector in the same direction as U. So there's U. We need a unit vector in the same direction as U. Who remembers how we find a unit vector, Jamal?
You find magnitude.
Find the magnitude. Stop right there. What would the magnitude of this vector be? It goes over 1, up 4. So its magnitude would be the square root of 17. That's step one. You want to find a unit vector, you do just what Jamal said. Find the magnitude. Then what? Jamal?
And then you put both x and y over the.
Exactly. You take your x and your y, and you put them both over the magnitude that you found. That's it. It's that simple. And then you simplify this. So that would reduce to, or rationalize to root 17 over 17 and 4 root 17 over 17. Okay? Now, when I look at your practice quiz, we did a lot of the problems. We haven't done them all. We got a few minutes, so let me give you a couple extra problems to practice. Are you okay with that? All right, so here's a couple that weren't hit on that old quiz. Suppose you have a picture that looks like this. And it says, literally, find the components. Of the vector shown. So here's the vector shown, and your job is to find the components. Okay, now wait a minute. Find the components. What does that mean I'm looking for? X and Y. I need to find X and Y. So my answer is going to look like this. This is the answer to the question. Now, who remembers how to get X and Y out of that picture? Sam.
So you draw your triangle.
You make a triangle, absolutely.
And then you have.
What's this?
Your x.
That's X.
And your y.
And this is Y, okay?
And then you well, I guess if you want to find the x first, right?
Yeah.
So it would be adjacent over hypotenuse.
Yep.
So goes up.
Yep, so you're gonna say cosine 57 equals x over 10, just like he said, adjacent over hypotenuse. So what will x end up equaling? I'm gonna go to my calculator and type this in. What am I gonna type in? No. I'm gonna type 10 cosine 57. I never press second cosine unless I need to know the angle. Do I need to know the angle in this problem? No, I know it already. I only do second cosine or second tangent or second sine if I'm finding the angle. If I already have it, it's a straight cosine or tangent or whatever. All right, so what did you get for x? Help me. 10 cosine 57. 5.45? All right. Now I need y. I could, but it's easier because of the decimal. It's easier just to do what? You sine, yeah. So sine 57 equals x over 10. So x equals 10 sine 57. Now, could you use the Pythagorean theorem? Yes. That is not wrong. It's more work and round-off error. It's easier just to type 10 sine 57. And that is, and there are your components. That easy. All right, another one that you're responsible for. Suppose I gave you the vector -2, 5, and I said find magnitude and direction. All right, now part of that's easy. Magnitude is easy. If you draw -2, 5, what will your magnitude be? Square root of 29. So that part's easy. How do we get magnitude? That's when we do the Pythagorean theorem, right? Now I need an angle. We're going to find this angle right here, okay? Now, what did I just get done telling you? If you're looking for an angle, you're going to use your second button, right? Now, what function are you going to use? Are you going to second cosine, second sine, or second tangent? Look at what you've got there. I would tangent, because don't I have y over x? So I know the tangent of that angle is 5/2. Now, take or leave the negative. It's up to you. It makes no difference. I don't need it. I'm not going to put it in. If you want to put it in, you're going to get a negative answer. That's fine. You have to deal with it. Second tangent, 5/2. Oops, sine radius. I got 68.2. Anybody agree? Now, if you tell me the direction angle is 68.2, you're going to get half credit. Because you got the right size of the angle, but you didn't name the direction angle. Where do all my angles start being measured? Unless it's a ship problem or a plane problem, everybody starts getting measured where? Right here. This is the answer to the question. So what would be the measure of my angle? 180 minus 68.2, which would be 111.8, if I did my arithmetic. Now, unless your vector is in quadrant 1, you are always going to have to make an adjustment, right? If it's in quadrant 2, we're going to take 180 minus. What if your vector had been in quadrant 3? What if the 68 had been here? Then how would you find your direction angle? 180 plus? What if it had been in quadrant 4? What if you had a 68 here? How would you find that one? Subtract from, not 270. 270 is not involved in that picture. What sides are involved in that? That's not 270. That is, well, 360. Right? It would be 360 minus. All the way around is 360. You didn't go that last 68, so it would be 360 minus 68, right? Pay attention to which quadrant you're in. One more problem. Let's suppose we have an airplane flying on a course of, let's say, 315 degrees at a speed of 187 miles an hour. Draw it. Draw that situation. Draw the vector that represents that situation. Keep in mind, this is a direction, this is a compass. So you're not going to do it like these. It's different than these. Which quadrant are you drawing your vector in? You're drawing in the 4th quadrant? I don't think it's in the 4th quadrant. You're drawing it in quadrant 2. And the reason we're drawing it in quadrant 2, kids, I'm not going to keep saying this. If it's a direction problem, this is the setup. Period. It doesn't change. That's your compass. Where's 315? Is it between 90 and 180? Heck no. Isn't it between 270 and 360? Yeah. So you're going to draw it up here like this. And then you're going to mark this angle 315 degrees, because that's the angle that you drew. And then you're going to say the magnitude of that vector is 187. And that is a picture. From that, we can then answer questions, but that's not on the quiz tomorrow, On the quiz tomorrow, all you have to do is draw the picture. Everybody clear? All right, your homework tonight is in the book, some parametric equations. But the first thing we will do tomorrow is take the quiz. And then we will start reviewing to prepare for our big quest